What up everybody, InstructaBeats back again here with another area lesson. Today we're going to be talking about finding the area of a rectangle with fractional sides. Okay, so let's open up our secret objective today. Our secret objective today I will be able to find the area of a rectangle that has fractional side lengths. Okay, so we've done area with whole numbers, but how does that change when the length and width are fractions? This message will self-destruct in T-minus 3, 2, 1. Agent Zero just went missing 2 weeks ago. Before he left, he sent this to you. It says, Agent in training, this is the last letter I could send before they close in on my location. Decipher this and discover my location. And this is what they left you in the letter, right? We have a rectangle, 2/3 of a meter on one side, 3/4 of a meter on the other side. And the question says, what is the area of this figure? Let's take a look at our key thought though before we solve this. Our key thought, straight from headquarters. There are two ways to solve this problem. The easy way, which I'm sure some of you have already started to figure this one out, maybe even have the answer in your head. And the conceptual way, which takes a little bit more brain power. So let's dive back into this problem and see if we can help out Agent Zero. So of course the easy way is just using our area of a rectangle formula, right? Length times width. So if we just plugged in our 2/3 here, right, and our 3/4 here, and we multiply across, we're going to see that the area of this rectangle is 6/12 meters squared. And so that's just using our area formula knowledge, right? So our answer is going to be 6/12 meters squared. And that's how you can get the answer. Let's talk about why we get that answer. And to do that, I wanted to cover it with this array right here, right? So we have the length of this rectangle being 3/4, okay? We have 1, 2, 3. So if the length is 3/4, obviously these need to be equal groups on this side. So if we split that into our unit fraction, the length of one of these cubes right here, right? So from here to here is going to be 1/4, right? Because it'd be 1/4, 1/4, and 1/4. We can do the same thing on the other side, right? So our width for this would be 2/3. And so we would have to decompose this into equal groups on this side too, right? So that would be 1/3 and 1/3. So this is really important to understand that. Because before we're doing an area, we're trying to figure out how many square units we need to cover the shape. Well, guess what? This is no longer one square unit. If these were whole numbers, then yeah, this would be one square unit. But because we now have a fractional side, our area for each square or tile that's covering our shape is not one. Each square tile that's covering our shape is like this little mini thing right here that has a length of 1/4 and a width of 1/3. So if you multiply those together, right, to find the area of just this one little piece, 1/3 times 1/4 would be 1/12. So each little tile piece right here is 1/12 meters squared, right? That one is, this one is. Matter of fact, all of them are. Because each tile, again, no longer has a side length of 1, like if it was a whole number, but it is 1/4 and 1/3. This one would be 1/4 and 1/3, right? And so now we have 6 groups of 1/12. And of course we have 6 groups of 1/12. That gives us 6/12. So we get the same area for our rectangle that we did with the shortcut, except we broke it down into why that's your answer, not just how you got that answer. So I know that might be a little bit confusing because we like to plug and chug for area and just plug in numbers and use the formula. So let's take a look at one more envelope to really stamp our learning. So in this envelope, right, we have 4/9 and 5/6. We're trying to find out, hey, what is the area of this rectangle? So if I do it the easy way, right, and just do length times width, I'd multiply across, right, and I'd get 20/54 inches squared. Okay, so I know that this is going to be my area. Again, that's kind of the shortcut. But now let's cover this back up with an array and look at not just the shortcut, but how we got to that answer. All right, so here's our array, and we can see this side was 4/9, right? So again, if we break this part in the unit fraction, each one of these has to be 1/9, because 1/9 plus 1/9 plus 1/9 would give us a width of 4/9. Same thing over here, right? So we know that this length is 5/6. So if we decompose that into 5 equal groups, right, each of these would be 1/6. And again, because these are fractional sides, now this is not one square unit, right? Like it normally would be if these were whole numbers. The area of the tiles basically that we're covering our rectangle with has changed. We need to find out, hey, what is the area of each of these? And if I have 1/9 and 1/6, right? 1/9 times 1/6. And if you need to draw this out, you can check out our how to multiply fractions with a grid. I'm just going to do the shortcut here. Would say 1/54, okay? Inches squared. So each of these is 1/54 inches squared. And if you add them all up, right, we have 4, 8, 12, 16. That makes 20 of them, right? So if you had 20 groups of 1/54, and I forgot to show you this math in the last one, just kind of assumed you knew it, well, guess what? That would be 20/54, right? 20 groups of 1/54 is 20/54. So again, coming to the same answer as our shortcut, but doing it in a conceptual way, hopefully helping you understand why we got that answer, not just how we got that answer. Right, again, thank you so much for checking us out today. We know there's lots of different options online. We really appreciate you. We love if you would subscribe, comment, like the video. Let us know where you're watching from. Check us out at InstructaBeats.com for all our merchandise. Again, thank you so much. InstructaBeats out.